This two-part video series demonstrates how you can use the parallel chart to identify the design that best meets the requirements of a product. In Part 1, we'll discuss the purpose of the parallel chart and show how parameter and design point information is displayed on the chart. For our example, we'll look at a printed circuit board. We want to minimize the thickness of the board while ensuring that the board can withstand a given inertial load. We have a solved study that has 4 parameters. Let's look at the parameters now. First, open the Design Points dashboard by clicking its icon. Then, click the Parameters tab. Now, for this study, our inputs are P1, the board's thickness, and P2, the inertial load on the board. Our outputs are P3, the maximum equivalent stress, and P4, the maximum displacement values, given a specific combination of board thickness and inertial load. The parallel chart is at the bottom of the Design Points tab. The parallel chart provides a graphic representation of all the design points and parameters in the table. When there are many design points, it is an effective tool for exploring the parametric space and assessing parameter impacts and relationships. We can move or maximize and minimize the Design Points dashboard. We can resize the chart by dragging its upper edge, and we can click here in the center to maximize the chart. Each y-axis represents a parameter. Both inputs and outputs are shown. When we mouse over a parameter, its full name and units are displayed. The numbers at the top and bottom indicate the upper bound and lower bound for the parameter's range. Each curve in the chart represents a design point. If we mouse over a curve, the curve is bolded. The design point's name and the values for each parameter are shown. We can click on the curve to select the design point. Note that the table and chart are fully synchronized, so the changes to one are also reflected in the other. The red curve is the design point designated as current. Now, from the table and chart, we can see that all the variation has occurred for P1, the board thickness. We also want to review the response to variations of P2, the inertial load. So, let's add a few more design points. We'll add 10 design points by duplicating dP0 through dP4 twice. For the first 5, we'll give P2 a value of 19620, or 2 times the original inertial load. For the second 5, we'll give P2 a value of 39240, or 4 times the original inertial load. The new points are added automatically to the chart. Because the new design points have not been updated, however, there are no output values, and they are shown as undefined. So, let's update the 10 new design points. When the update completes, the output values of the new design points are shown in the chart. This concludes Part 1 of this video series. In Part 2, we'll show how to manipulate the parallel chart in order to find the most promising designs for our product.